All right, everyone. So in this problem, we're trying to figure out the total charge of 750 grams of protons. So if we have 750 grams, we first have to figure out how many protons that is. 750 grams, remember, is the same thing as 0.750 kilograms. And for every one proton, it has a mass of 1.67 times 10 to the minus 27 kilograms, which when you divide, you find that the number of protons is 4.491 times 10 to the 26th protons. To figure out the total charge, I don't know what's happened with some of that sometimes. Figure out the total charge. We're just going to multiply the number of protons, 4.491 times 10 to the 26th, times 2, times the charge of a proton, 1.602 times 10 to the minus 19. And we find that the total charge if you have 750 grams of protons, would be 71945,820 coulombs, or 7.195 times 10 to the 1, 2, 3, 4, 5, 6, 7th coulombs. That's a lot of charge, but it'd be really hard to have 750 grams of protons all just in one place. So one of the things we discussed this week was Coulomb's law. And Coulomb's law gives the electric force, or the force between two particles with electric charges that are separated by some given distance. In this equation, we use the electric force constant, which is 8.99 times 10 to the 9th newtons meters squared per coulomb squared. You can also, this is sometimes just 9 times 10 to the 9th. Either way will work, and this one's a little bit easier to remember. And so let's try a couple of problems where we want to find the force between two particles. So first we have a hydrogen molecule, consists of two hydrogen atoms whose nuclei are single protons. Find the force between the two protons in a hydrogen molecule whose distance is 6.8 times 10 to the minus 11 meters. That's how far apart they are. So R is their distance apart in the equation, 6.8 times 10 to the minus 11 meters. They're both protons, so they have the same charge, Q, 1.602 times 10 to the minus 19. And we know the constant, we'll just use 9 times 10 to the 9th. And so to find the force, right, the electric force between those two objects, or those two particles, 9 times 10 to the 9th times 1.602 times 10 to the minus 19. I don't know why it does that. And now there are two protons, so we need to multiply it times the charge of each. Right, Q1 for the first one, Q2 for the second one, and then our constant, our electric force constant, divided by R squared, so 6.8 times 10 to the minus 11 squared. Now, the biggest problem you'll likely have with solving a problem like this is plugging it into your calculator. And so my suggestion is always to multiply the numerator values first and then divide by the denominator. Whichever way you do it, just make sure that you're using the exponents in your calculator correctly. If you do this, you should get 0.000, should be 7 zeros, 5, which is 5 times 10 to the minus 8 newtons. It's a very small force. But if you calculate the gravitational force between those two protons, it is much, much smaller. It's like 10 to the minus 26 or 35 or something like that. So let's try another problem. Here we just have two random charges where we want to find the magnitude of the force on each charge. One thing to point out is that the force on each charge will be the same, right? Remember, this is Newton's law still holds here. So the force on one is equal to the force on the other. Equal and opposite forces. And so, to find the magnitude of the force on each charge, we're going to use Coulomb's law. Again, we have the electric force constant, 9 times 10 to the 9th. We have a charge of 2 times 10 to the minus 7 coulombs, and then negative 7 times 10 to the minus 6 coulombs, divided by their separation distance is 11 centimeters. That's how far apart they are. 11 centimeters is 0.11 meters. Excuse me, I'll just change my notes here. 11 centimeters here. 11 centimeters is equal to 0.11 meters. Remember, we want to keep things in meters and newtons and kilograms if we can. And so 0.11 meters. So we're going to square that. Once again, the trouble here will generally come from your calculator, so just be careful how you do this. Multiply the values in the numerator, divide by the denominator, and you should find that you get here 0.012586 divided by 0.11 squared, which will give you 1.04 newtons. And this will be the force on each charge. Okay. The force is technically negative. This means that it is attractive. If we have a positive charge and a negative charge, they will attract one another. They will pull towards each other. If we had a positive charge and a positive charge, they would repel one another and they would push away from one another. And you would have a positive force rather than a negative force. Okay. We also talked about electric current this week. Current in a wire is defined as the amount of charge that passes a point in some unit time. Right? So the amount of charge per unit time is how we measure current. Current's measured in amperes or just amps, and 1 amp is equal to 1 coulomb per second. And remember, 1 coulomb of charge is a lot. And so 1 coulomb of charge passing any point in 1 second is a lot. 1 amp of current is extremely dangerous. Most currents are much, much less than that. So some instruments can be sensitive to the passage of as few as 47 electrons. And so we want to know how much current that would actually supply. Well, 47 electrons is going to have a charge, when we multiply it, times the charge of 1 electron. We have 47 of them. So 47 times the charge of 1 electron will give us 7.529 times 10 to the minus 18. And that's how many coulombs pass. If this is 47 electrons per second, so that's coulombs per second, this would be our current, 7.529 times 10 to the minus 18 amps. That is an extremely small current. Much, much less than what you might see in regular things. Most everyday objects are going to have currents between milliamps and a couple of amps, depending on what the object is. We also talked about Ohm's law and electric circuits. In an electric circuit, the potential difference, or the voltage in the circuit, is proportional to the current, and the constant of proportionality is the resistance of the circuit. And the resistance of a circuit comes about from the components that make up the circuit, the wires, sometimes things like resistors and all the other components that are built in. And so the resistance is a function of the physical components of the circuit itself. And it restricts the flow of current based on the voltage that's applied across the circuit. Resistance in a circuit is measured in ohms.